A line passes through the point A having the coordinates 4, -1 and is parallel to another line 3x minus 4y plus 1 equals to 0. Determine the coordinates of the 2 points on this line which are at a distance of 5 units from A. Okay, let us begin. First, let's do one thing. Let's try to understand the problem graphically. So we'll begin by considering the point A and the line 3x minus 4y plus 1 equals to 0 on the coordinate plane. So here we have a line L which is going to pass through the point A having coordinates 4, -1. It's given that this line L is parallel to another line 3x minus 4y plus 1 equals to 0. Our goal will be to determine the coordinates of 2 points on this line. So that means on the line L, which are at a distance of 5 units from A. So here, what we'll do, we are going to consider 2 points. Let's say those 2 points are point B and the point C. So this is our point B and we have our point C. And both of these 2 points are 5 units from the point A. That means BA, that is going to be 5 units, and AC, that is also going to be 5 units. This much information is given to us. Our goal will be to determine the coordinates of the point B and C. So here, to find out the coordinates, what we'll do here is use the distance form of a line. So let's quickly recapitulate the distance form of a line. The distance form of a line is given by x minus x1 divided by cosine of angle alpha. This is going to be equals to y minus y1, that means the difference of the y coordinate, divided by sine of angle alpha, and that is going to be equals to r. So let's try to understand what are the parameters that we have used here. This simply means that we have, let's say, 2 points. One of the point has got the coordinates x, y, and the other point has got the coordinates x1, y1. And then we have a straight line which is going to pass through these 2 points. The 2 points whose coordinates are known, and also let's say that the distance between these 2 points, that's denoted by r. So this is what the r means here, and alpha is going to be the angle that this line makes with the positive direction of x. Then what we get here is referred to as the distance form of a line. This is referred to as the distance form. Okay, now first what we'll do, we will try to figure out what is the value of alpha. Okay, now it's given here in the problem, the equation of the line 3x minus 4y plus 1 equals to 0. Now from this line we can easily determine the slope of that line, and once we know the slope of this line, we can also define the slope of line L, because we know that 2 parallel lines have got equal slope. Okay, so we have the equation of the line given as 3x minus 4y added to 1 equals to 0. So what we'll do, we're going to rewrite this equation in the form y equals to mx plus c. Now what is mx plus c here? M is the slope of the line and c is the y-intercept. That is the y-intercept. However, we don't need the value of the y-intercept here. We only need the slope value. So let's try to rewrite the equation in this format. We're going to get 4y, that's going to be equals to 3x plus 1. Dividing 2 out by 4, we get y equals to 3 over 4 times x added to 1 over 4. So here what we have done, we have obtained the value of m when we compare with the equation y equals to mx plus c. The m comes out to be 3 over 4. And what is m here? M is the slope, let's call it L prime. So m is the slope of the line L prime. But we know for a fact that L is going to be equals to ml prime. We can say slope of the line L equals slope of the line L prime, and this is also going to have the value 3 over 4, since the 2 lines L and L prime are parallel to each other. Okay, so we've obtained the value of ml, and we know what is ml. This is simply going to be ml or ml prime. This is simply going to be the angle that the line makes tangent of the angle alpha, where alpha is the angle that the line makes with the positive x-axis. If this is angle alpha, obviously the line L also makes an angle alpha with the positive x-axis. So tangent of alpha comes out to be equals to 3 over 4. But if we look at a problem, in the distance form we need cosine alpha and sine alpha. We have only tangent of alpha. So we need to figure out the value of cosine of alpha and sine of alpha. Okay, so there are several ways of doing it. The best way would be to consider a right angle triangle ABC, which is right angle at B and C has got the angle alpha. So if we take tangent of angle alpha, we know tangent of angle alpha, that is defined as the opposite to that of the adjacent. That's BC, and since this ratio is 3 to that of 4, so we can say that AB is 3 and BC is 4, and using the Pythagoras theorem we can find out the value of the hypotenuse AC, and comes out to be 5 units. So now that we have the length of the three sides of the triangle, we can easily define the value of cosine alpha as well as sine alpha. So what is cosine alpha? Cosine alpha, that's going to be the adjacent to that of the hypotenuse, that means BC over AC. So BC over AC, or simply put, we get 4 over 5. And sine of alpha, that's equals to, so sine of alpha is the opposite, which is AB, divided by the hypotenuse AC. So AB over AC, that is equals to 3 over 5. Okay, so we have successfully obtained the value cosine alpha and sine alpha. Now what we'll do, we're going to apply the distance formula. So for this, let's look at the diagram here. So in order to apply the distance formula, we need 2 points. So here, if we consider the line L, we have actually 3 points, B, A as well as C. We have the coordinates of A. So what we need here is the coordinates of B and C. Well, we're going to specify the coordinates of B, and let's do that first. So here we have, suppose that the coordinates of B and C are x1, y1 and x2, y2 respectively. Okay, so what we'll do here is we will consider 2 points at a time. So let us consider the point. Let us consider the point A and the point B. Now, we will try to figure out the coordinates of point B, taking the help of the coordinates of point A and the distance form. So here, when we apply the distance form, one thing that we need to be careful here is, as we can see here, that point A lies to the right of the point B. So it simply means that the coordinate value of A is going to be greater than that of B. So here what we can do, we'll consider 4 minus x1, because the coordinates of B that are x1, y1. So we need the difference of the x coordinate. So we do 4 minus x1 divided by cosine of the angle alpha. So we obtain cosine of angle alpha as 4 over 5. So here we replace cosine of alpha with 4 over 5. This is going to be equals to, now next what we need is the difference of the y coordinate. So we do -1 minus y1 divided by 3 over 5. That's the value of sine alpha, and this is going to be equals to the distance between the points A and B. So that's already given in the problem as 5. So now we solve this, and this is going to help us obtain the value of x1 as well as y1. So what we'll do, first we consider 4 minus x1 divided by 4 over 5, and let's equate it to 5. And then separately we're going to equate -1 minus y1 divided by 3 over 5 to 5. So we cross multiply to get 4 minus x1 equals to, so 4 over 5, when multiplied to 5, that simply leaves us 4. So solving for x1, we get x1 to be equals to 0. Next, we solve for the value of y1. So here we have -1 minus y1, so that is going to be equals to 3 over 4 multiplied to 5 leaves us with positive 3. The y1 must be equals to -1 minus 3, that's going to give us -4. So here we have successfully obtained the coordinates of point B as 0, -4. Okay, next what we'll do, we're going to apply the distance form to the points A and B, and that's going to help us obtain the coordinates of the point C. So let's do that. So now we have the point C. Since point C lies to the right of point A, we will consider C to be greater than A. And now we have the difference of the x coordinate. So we have x2 minus the x coordinate of point A. So that's 4. Divided by, first let's write down the angle, cosine of angle alpha. This is going to be equals to the difference of the y coordinates. So we have y2 minus -1. So we get y2 plus 1 whole divided by sine of the angle alpha. And that is going to be equals to the distance between the 2 points AC, which is given as 5 units. So here we have x2 minus 4 divided by cosine of angle alpha, that will be equals to 5, or we can say y2 added to 1 whole divided by sine of angle alpha, so that's equals to 5 as well. So x2 is going to be given by 4 added to 5 over cosine of angle alpha, and y2 is going to correspond to -1 added to 5 sine of angle alpha. So let's use the value of cosine alpha and sine alpha. So cosine alpha was 4 over 5. So we have x2 equals to 4 plus 5 multiplied to 4 over 5. And then for y2, we have -1 add to 5 times 3 over 5. So 5 and 5 gets cancelled out. 5 and 5 gets cancelled out. And x2 comes out to be equals to 8. And y2 comes out to be equals to positive 2. So here we have obtained the coordinates of point C as 8, 2. So we have completed the problem. So let's write down the final value. Thus, the coordinates of the points B and C are going to be, so B came out to be 0, -4, and the coordinates of point C came out at 8, 2. That's the final answer.